Alright guys, I think I fixed the audio problem, but we'll find out when you judge me tomorrow. Anyway, as you can hear the 3D printer in the background, I'll try to talk over it. But let's face it, I need some 3D printing done tonight. Anyway, as you can see, I want you to try this warm-up out. Obviously, you need to copy the picture, and then I'm going to scroll down so you can have your questions. So naturally, pause it for this, then pause it for that so you can copy it correctly. Again, pause it when you need to. Let me make sure I don't have answers on the other page. Ah, good. So go ahead and pause it, give it a shot. Yes, I'm talking to you. Again, sorry the printer's loud. Alright, so we're back. Guys, I like to just go around the circle sometimes and just fill in stuff that I know. I find it to be the easiest thing to do. And I'm a little scared because I'm at school all by myself. Creepy. So, anyway, just eyeballing this thing, we got a 40 here. Divide by 2 to go in, because the vertex is on the circle. I'm going to argue that this little angle right here is 20 degrees. 60 is central, moving out, 60 degrees. Yes, this is the center. C is the center. I forgot to put C. Keep going. This is a diameter, which means this whole thing is going to be 180. Can y'all see that? This whole thing is 180. So 180 minus 60, 120 is going to be this arc. Again, central angle moves in. This should be 120 as well. Vertex is on the circle, times by 2 to move out, and we get 70 degrees. Now, frankly, again, leftovers, this side should equal 180, so 70, 40, 110. So, should be 70 degrees. So let's check that. 70 is 140. 140 plus 40, 180. I think we solved everything we could. So let's see if we can fill in these blanks. Arc TP, done it, 60. Skadoosh. PR is over here, did it, 120. So that's a 120. I'm trying. Angle, LTR, LTR. Okay, did y'all see that? Here, let me try to make this. I'll do a highlighter tool. Starting at L, go around the circle to T, keep going to R. Literally, that's all of this. So my shortcut would be 360. Oh, gotta get my pen tool. 360 minus that little 40 will give us 320 degrees. RCP, let's see, that's a R, C, center, P, again, central angle should be the same, 120. That's 20. Arc MT is over here, 70. What else we got? ML, we just solved that to be 70. And scroll down a little bit. TMR, that's a semicircle, so 180, no brainer there. RPL, RPL, is that the same thing as LT? Oh my gosh, guys, that's an angle. What is wrong with me? If you look, like RPL goes all the way around, that's 320. I completely ignored this angle. That ain't right. LTR is at 20 degrees. Sheesh. I know someone's making fun of me. Look, it's late. Just got back from White County. Get off my back. You're not my dad. Minor arcs, remember, are less than 180 degrees. I'm just going to put TP because, you know, I see it there. It's less than 180. Anything, as long as it's less than 180. Major arc, shoot fire. I think I want to go TMP because I can. TMP. Skadoosh. Anything greater than 180. Semicircle, I'm just going to go ahead and say TPR. TPPR. I've seen better. I want to figure out what's causing this thing to slow down, so give me a second. Okay. Maybe this will speed things up. Let me get a little field test. Maybe. I don't know. I had a lot of windows open, so I closed some of them. Anyway, so hope you got the right answers. Moving on. Again, we're still talking about inscribed angles. How can I find the measures of central, inscribed, and circumscribed angles? Ooh. Get this sheet off the table next to the Chromebooks and start working on it. Well, I don't remember that being there from last time. I'm going to scribble that out. And pretty sure you already have this worksheet anyway, but we're skipping this. Skipping that too. Skipping that. Skipping that. Here we go. I don't know who put those worksheets there, not I. This is what I wanted to get at. Today we are going to learn how to find the measures of angles formed by chords, tangents, secants. Specifically, we will focus on inscribed and circumscribed angles. Remember, this is a secant because it intersects it twice. A line that intersects a circle twice. This is a tangent. Okay. Intersects it once. I might even argue we can use the word scaling for this. I don't think we can. I really don't know. I do know that this is nothing. No relationship here. Line is way over here. The circle's over here. There's probably 1,000 miles in between because I walked it. I walked those 1,000 miles to be that man who walked 1,000 miles to be the man. All right, I tried. So, if there's anything to jot down, might be this. There are 3 categories of angles formed with secants and tangents. Vertex on the circle. We've seen this before. Notice where these lines are intersecting. A secant and a tangent line. 2 secants. Inscribed. This on idea, remember, that's at times 2 or half. Okay. Okay, get everything. There you go. Second one. Vertex is inside the circle, interior. See the vertex inside. Notice it's not the center. That's the center. This is not the center of the circle, because remember that follows different rules. We're about to unload some rules on you right now, but right now we need to understand this is inside the circle, but not the center. Not center. Can't say that enough. Probably can't write it enough either. Try to make a smiley face. That didn't happen. Skadoosh. That guy looks a little evil. Why aren't any tangents included here? Well, probably because tangents only intersected once. So if we did have a tangent, we'll wind up having, well, come on screen, we'll wind up having this guy over here. Remember, tangents only intersected once. So if we were to move this line, maybe over here, we would force this line to turn into a tangent, and it won't be inside the circle anymore. It would be on. So we might even argue that tangents will always be on the circle, not inside. Okay. Again, pause. You can go back, pause the video, rewind if you need to. Category is tree. Tree. Vertex is outside the circle. Circumscribed, which means you could have two tangents intersecting at once. You could have two secants, again, intersecting twice on the circle. Or you could mix it up and do a tangent over here and a secant line over here. Again, we're about to go over these rules. Okay? So, excuse me. The measure of an inscribed angle with its vertex on a circle is half the measure of its intercepted arc. So, what is the measure of AVC? AVC on the circle, which means you go half, or you divide by 2 or go half. So 150. I think it's 75. Of course it is. Go away, drive storage portal. So it is indeed 75 degrees. This is the same rule as what? Again, that on the circle. I can't stress how you need to figure out where these vertex are. That's how I know these rules. It's on the circle, so you're either doing half or times 2. With this rule, man, I cannot say this word. Would this rule work if VA was a chord instead of a secant? Yes, because we already saw this example. Okay, I remember our examples. We literally had this chopped off at the edges of the circle. Okay, still works. The measure of the interior angle with its vertex inside, again, not the center, inside a circle is half the sum of the measure of the arcs intercepted by the angle and its vertical angles. Okay? So, what I'm trying to tell you is the measure, okay, of arc 1 plus the measure of arc 2, okay, half that, half the sum should equal the measure of said angle. Now, I don't know really how to label this. I'm just going to put measure of angle. So, in layman's terms, here's arc 1, here's arc 2 for this argument, here's our angle. Vertical angles means it would be the same thing over here, so it doesn't really matter. If anything, you're kind of solving for both anyway because of vertical angles. So plug in what you know. We're going to go 80 plus 40 divided by 2 equals that measure of that angle. We're doing AEC right now. So 80 plus the 40 equals 120. Divide that by 2. Well, you can do that in your head. It should be 60. And that's what this angle will be. 60. Vertical angles makes this 60. Bed. I want to go to bed. We've already just discussed this. This is vertical angles. They both should be 60. This is a linear pair. The fact that they're 60, that means this should be 120 over here. Again, vertical angles 120 over here. Mind-blowing stuff, I know. Okay, moving on. Again, the measure of the circumscribed angle formed by two secants, or two tangents, or a secant, and a tangent that's intersected outside a circle is half the differences of the measure of the intercepted arcs. So, I like to think of it like this. Arc 2 minus arc 1, again the measures, divided by 2. Difference means to subtract, should equal the measure of that set angle. Okay? Another way to say it is a bigger arc minus smaller arc all divided by 2 equals measure of said angle. This is arc 2 bigger minus this arc right there, double arrow. Arc 1, do you see that? I'm talking about this guy right here. Okay, that arc. This right here at the V is the angle I'm talking about. This is the measure angle that we're talking about. Again, vertical angles means the same thing over here, but you say tomato, I say potato. So plug in what you know. We know it's going to be 80 minus 20 should all be divided by 2 equals that measure angle. Yes, that's an angle shine, not a C angle. So 80 minus 20 is 60 divided by 2. We get surety. Surety is that angle right there. ABC is what we just solved for. So think about this. We got 3, maybe we could argue 4 formulas. Central angle is going to be the same as the arc. If the vertex is on, you got to half it to get to the vertex, or double it to get from the vertex to the arc. We just went over if it's inside, you add the arcs up, then divide by 2. And if the vertex is on the outside, you subtract the bigger one and smaller one and divide that by 2 to get that angle. Hope we're writing this down. Hint, stupid drive stories. Oh. Okay, moving on. Boop. Practice problem. As always, you know the game. Hit pause and try to solve it on your own. Alright, now that we're back, after you've drawn the picture, honestly, just label what's given. AVC. AVC. That's right here. That's going to be 60 degrees. Measure of AC, that's over here. See, that arc is going to be 130. Find BD, that's over here. That's X. Ask yourself, where's the vertex? It's on the outside. That means we're subtracting. Bigger minus smaller. So 130 minus X, because I don't know it, all divided by 2, and it should equal that angle, which is 60. And as I say before, you should be pros at solving. I suggest we get rid of the denominator first. Times both sides by 2. 2's cancel. We get 130 minus X equals 120. Subtract 130. We get negative X equals negative 10, but divide by negative 1 to get rid of the negatives. Going to draw a little arrow here. X should equal 10 degrees. BN. Yep, you're right. I got more for you. Cool. Ooh, this one looks tough. If you notice, I'm starting to combine rules. Okay. So go ahead and pause the video. Give it a shot. And then we'll talk about it. Alright, I'm back. This one, excuse me, this one looks tough. T's the center. We got a tangent. Okay, we need to find WXY. WXY. Okay, we need to find measure of U1 here. And then we need to find measure 2. Guys, this does look pretty tough. But if you just take a look, it's easier than you think. For example, all these circles should add up to 360, right? I don't know this hard, but if you notice, I'm going to kind of doodle it. Here's 130. Here's 90. Here's 20. You only have this piece left. That's right, you're getting it. 360 minus 130 minus 90 minus 20 should give us that leftover piece. So Man, I swear to everything, I'm going to burn that Google Drive message to the ground. In fact, I don't even know if y'all can see it. I hope you do. Then you'll understand my frustration. Because I think it's blowing the speaker, but I'm not sure. Because I'm recording this now, and I won't know until tomorrow when you tell me it does. Weird. It's like I can see the future. Anyway, now that we have all those arcs, let's see if we can answer some questions. WXY. W, X, Y. Shoot, that vertex is on the circle. It's half that arc. Just say divide by 2. That bad boy is going to be 60 degrees. Yeah, nailed it. M1, inside the circle. That's the sum of the inscribed arc. So that's going to be this 90 and this 120 we just solved. So yep, that's right, 90 plus 120. Doesn't matter which one's first because you're adding. Divide by 2, so 90 plus 120 gives us 210. Divide that by 2 and we get 105. And that's for the measure of angle 1. We'll put that up here. See, easier than you thought. 2, outside. That's the big arc. And I'll put it in red. Big arc. And I hope you can see it. Trace the lines here. So big arc's 130. Subtract baby arc here, which is 20. All divided by 2. And we get, see, 130 minus 20 divided by 2. And we get 55. So 55. Is that real? Ugh, I don't like that number. I know someone just made fun of it. Try that. Oh, yeah. Looking good. Boom. Easier said than done, I guess. Whatever the expression is. Okay. I hope you got it. Good job. Smiling face for you. Yes, okay. You can have one too. Boom. Boom. Oh, too much. Now, this looks like a nightmare. So does this time. I'm at 22 minutes, and I'm already gone too far, in my opinion. That, and I think I already have the answer key for this. So, if you wish to challenge yourself, which I hope you do, I would jot this picture down. I think I'll have it on the handout anyway for you. And see if you can't solve. You're using all the properties we just discussed. You can do it. I believe in you. Also, A is the center. Okay? Make a blue dot. Same thing for this one. I believe in you. You can do it. I give you smiley face. But again, I think I should have the answer key being posted. If not, we can go over it together when I get back. Or I guess we'll be in class when we do this. Anyway, ignore this because you already have this online in your notes. Again, you're just solving for these missing angles. Look right here, solve for x, assume the lines appear tangent, arctangent. Guys, this is the arc. This vertex is on the circle, which means you would have to times the 70 by 2 to get that answer. So in hindsight, you should be going 2 times 70 should equal 141 x minus 1, and then solve for x. Okay? Just because they look scary doesn't mean you can't solve them. For example, vertex is on the outside. That means you're getting the difference here. So you should go 12x plus 8 minus, notice I'm going to put parentheses here because you're going to have to distribute that negative across the 4 and the, well, I guess the other 4. But I'm going to dress this up because it looks like a 9. And again, I already read someone's mind saying, hey, you need to think of 9. Yeah, I get enough of it all day. Boom. And again, you're supposed to divide all of that by 2 And all of this should equal that angle, which happens to be 50. Okay, a lot of work here, but you can do it. Being that there's a lot of work here and I already know someone's going to want me to do it, I'll go ahead and do it for you. Remember, distributing the negative, and we'll also need to get rid of this 2. I'm going to get rid of the 2 first. And I'm going to try to kill 2 birds with 1 stone. So 50 times 2 is 100 equals 12x plus 8. Distribute the negative, negative 4x, negative 4. Go away. You know what? Can I pause this? I want to pause this. I want to hit these arrows. Oh, I shouldn't have done that. Maybe I can pause thinking. Maybe it'll leave me alone. Go away, go away. All right. Combine like terms. We got 12x. Yeesh, a little too far gap there. Minus 4x. That's I guess 8x. 8, 4. I guess that's going to be 4. All that should equal 100. Again, we're solving for x. Minus 4. We get 96 equals 8x. Divide by 8. Let me check my calculator. And we get 12. Wow, I should have known that. What's wrong with me? Skadoosh. Remember, x is not representing a degree. It's just some variable. So it's okay if it's positive or negative. If x was representing a measure, an angle, then you better make sure it's positive, at least in this class. All right. Let me see if there's any other headaches for you. Again, you're adding these. I'll give you an answer key later. This angle is right there. That's what that represents right there. That's this right there. Again, follow the rules. Should be times it by 2. Again, ignore this. I'm going to give this to you. Rules still apply just because they look different. This minus that should equal this, after you divide by 2, obviously. Yeah. So give it a whirl, check your answer key. Again, over here, I know it looks goofy. It's this guy minus this guy. All divided by 2 should equal this guy. In fact, I'll go ahead and write that again. Come up 6 plus 14x minus 58. All of that divided by 2 should equal 2x plus 14. Again, should be pros at solving. Alright, I'm done here. And almost made it below 30. Oh, I forgot to give you your prize for watching the video. Today I will give you a flower. I know, I'm pretty amazing at drawing on this slate. Because y'all know how hard it is to draw on this slate. I think it's magic. Because I don't have to look at the screen or look at the slate and blah blah blah, a little smile. Oh, this is so pretty. A little blue flower. Gotta get some leaves toward the, I don't remember what chlorophyll. I really don't know what it's called. There you go. Oh, didn't even touch the ground. There we go. Draw some flower. Flower. Good looking flower. There's your gift. Be in.